Hello, my name is Jessica. I'm a fully qualified maths teacher and today's topic is trigonometry. And this first video is going to be on trigonometry finding sides, and then I will do a follow-up video of finding angles. Okay, so trigonometry and Pythagoras can sometimes get muddled up. Pythagoras is all to do with sides. I did a previous video on that, and it's where you have a squared plus b squared is c squared. And it's always sides. So you'll have two sides and a missing side, and you want to find that missing side, and that's Pythagoras. Trigonometry normally has an angle. Okay, so trigonometry would have a side and an angle. It could have two sides and a missing angle, or it'll have a side and an angle and you require to find a side. Okay, so the rhyme that we use to help with trigonometry is called SOHCAHTOA. SOHCAHTOA. Okay, so SOHCAHTOA. There are many different rhymes if you Google them to remember trigonometry that can help you. Personally, this is the one that works for me. So we SOHCAHTOA, so we have SOH, so this is sine equals O over H, and we could be very professional and say sine theta, because remember I said trigonometry always involves an angle. We have cosine or cos theta equals A over H. And then we have tan theta equals O over H. Okay, so sine, S, opposite, opposite, hypotenuse, hypotenuse. Cosine or cos theta is the adjacent, adjacent, hypotenuse, hypotenuse. Okay, so you see how the little rhyme works. SOHCAHTOA, this is for trigonometry. Trigonometry is where you will either have two sides and a missing angle, or a side and an angle, and you want to find the other side. Same as Pythagoras, right angle triangles. Okay, so let's draw a triangle so you can actually see what this is going to come out like. So here we have two right angle triangles. In this one, I'm going to say there's my angle, so there's theta. And in this one, I'm going to say theta is up there. Okay, so we're going to label these sides. So we know from Pythagoras that the sides opposite the right angle is the hypotenuse. So those are my hypotenuse sides opposite the right angle. And the side opposite the angle is opposite. So opposite the angle, opposite. And then the side that lies beside the two angles, so the right angle and theta, is adjacent, because adjacent means beside. Or if you can't remember that one, just remember it's the one that's left. So in this one, there's the right angle, there's the angle. On the same side beside those is the adjacent, or the one that's left. Okay, because some people find that one hard to remember. So we have SOHCAHTOA is the way to remember trigonometry. We have sine equals opposite over hypotenuse. Remembering the opposite is the side opposite the angle. Hypotenuse is the side opposite the right angle every single time. And adjacent is the one beside the two angles, okay, or the one that's left. Now, as I said in this video, we're going to do sides. So let's try a question. I'll draw it out in red the question, but I won't answer it in red. So here we have 7 centimeters, x centimeters, and we have an angle of 40 degrees. So how do I know that this is not Pythagoras? Because I've got an angle and I've got a side and a missing side. Okay, Pythagoras is always to do with sides, but because I have an angle and a side, I'm going to use trigonometry. Which one are we going to use? So SOHCAHTOA, okay, oops, I just rubbed that out, SOHCAHTOA. Then we're going to label our sides. So the one opposite the right angle is H, opposite the angle is O, and the one on the same side as both angles, or the one that's left, is adjacent. Okay, let's look at our SOHCAHTOA. And we need to say, right, I want this one, okay? I have got the hypotenuse, so we can tick all the hypotenuse, and I've got the opposite, okay? So I'm going to do that again in case you didn't follow. So we've wrote out our SOHCAHTOA, write it a bit bigger, KA-TOA, okay? I've written that out. I've realised it's trigonometry. I've got a side and an angle and a missing side, so I know it's trig. I know that my wee thing of remembering it is SOHCAHTOA, the wee acronym SOHCAHTOA. So I've labelled my triangle. So now I'm going to say, which one am I using? Okay, so it's all very well being able to label the triangles and being able to remember SOHCAHTOA, but how to actually apply that to answer a question can sometimes be tricky. So I've labelled it opposite the right angle, hypotenuse, opposite the angle, opposite, and beside the two angles, adjacent. So what do I have? Well, I want to find O, so I'm going to tick O. There's all the O's. I have got H, so I can tick all the H's. So the only one that I'm able to use is this one, sine, okay? Because I have got both O and H in my question. Opposite is the one I want to find, and hypotenuse is the one I want. We cannot use cosine because I don't have the adjacent, so that's no good to me. I can't use tan because again, I don't have the adjacent, so that one's no good to me. So we're going with sine. So write your formula first. Sine theta is opposite over hypotenuse. Then all we're doing, that is the hardest part of trig, okay? Identifying its trig, remembering SOHCAHTOA, labeling your triangle, deciding which one you're going to use, whether it's sine, cosine, or tan. And once you've decided that, all we're doing now is substituting in values, okay? So let's substitute them in. Sine theta, remember, is our angle. That's your theta. So it's 40 equals opposite, which is the one we want. Okay, we don't know that one. And hypotenuse is 7. Okay, so here's the missing one. So we're going to bring in a little bit of algebra to help us rearrange this. So what we're going to do is we're going to take the 7 up to the other side. I'm obviously using change side, change sign. If you use the balancing method, you would be multiplying both sides through by 7. So whatever way you do your algebra is up to you. So if it's dividing by 7 on the right hand side, then it's going to be multiplying by 7 on the left hand side. So sine 40 times 7 equals x. So x equals, so get your calculator. You'll see that there, I don't know if you can see my hands, is the sine, cos and tan buttons on my calculator, okay? So you can see there's my sine, cos and tan button. Okay, so those are the buttons we're going to use. So make sure you're comfortable and confident with your calculator. So I'm going to type sine 40. Okay, you'll notice it's like that. So hopefully you can see that. What I'm going to do is I'm going to close that bracket. Okay, so that my sine 40 stays all together. Then I'm going to click multiply by 7 equals. And you can see it's given me an answer there of 5.215, etc. Okay, so it's given 5.21579. So let's round that to 3 significant figures. First significant figure, second significant figure, third. Look to the one to the right of it. It's 5 and above, so we're going to go up. So it's going to be 5.22 centimeters. Now remember back to Pythagoras, we know that the hypotenuse side, this one of 7, is always the largest. Is 5.22 smaller than that? Yes, it is. So we've probably done it correct. Okay, let's try another one. If you obviously need to pause and try that one yourself, please do. So here's the next one. So the right angle triangle is kind of lying down this time. And we have got 13 centimeters, 35 degrees, and x centimeters, okay? First things first, identify the topic. We've got a side and an angle and we want a side, so it's trig. Why not Pythagoras? Because Pythagoras is all sides. So write your acronym, SOHCAHTOA, SOHCAHTOA, okay? We've identified its trig, we've wrote our SOHCAHTOA, let's label our sides. So opposite the right angle is the hypotenuse side. Opposite the angle is opposite, and the side beside the two angles is adjacent. Okay, now we go and tick off the ones we have. So O is the one we want, opposite. There we go. A is the one that we have. So you can see now the one I'm going to use is tan. So I'm going to write my formula. Tan theta equals opposite over adjacent, because this one we don't have the hypotenuse and we don't have the hypotenuse. So the only one we can use is tan. Then there's the hard part done. Okay, now all we're doing is substitution and rearranging. We're substituting in our values and rearranging to find the value of x. So tan 35 equals our opposite, which is the one we want, over the adjacent, which is 13. Again, we want x by itself and positive, so we're going to move the 13 to the other side. It's being divided by 13 on the right hand side, so it's going to become multiplied on the left hand side. Again, get your calculator, find your tan button. So you're going to type in tan 35, remember it comes up like that. And I want to close the bracket, so my bracket buttons are at the bottom. Multiplied by 13 gives me 6.1595. Again, I'm going to go to 3 significant figures. 1, 2, 3. Look to the one to the right of it. It's 5 and above, so I can round up. So 6.16 centimeters. Okay? Now, let's try another one. So, let's try this one. Okay, so I was just looking for a harder one there. Let's give this one a go. So it is a triangle like this. So again, right angle triangle. The angle is 50 degrees. We have x and we have 5 centimeters. Okay, so here we go with our, again, what's the topic? Well, we have got 2 sides and an angle, so it has to be trig. Let's write out our little acronym, SOHCAHTOA. Okay, let's label our triangle. Do you see how it's the same drill every time? Opposite the angle, the right angle is the hypotenuse. Opposite the angle is O, and the side on the same side as both angles is adjacent. Now let's take off what we have. So we have H. We want to find A. So the only one we can use is cosine, okay? Write your formula. Cos theta equals A over H. Okay, so all the hard part and all the thinking is done. All we're going to do now is substitute in our numbers. So cos the angle 50 equals A, which is X, over H, okay? So then what we're going to do is we're going to rearrange again. So we're going to move the 5 over there. So we have cos 50, again, don't forget, because on the calculator we will be closing our bracket, times 5 equals x. So x equals, so far we've done one of each of them, so this gives us a cosine one. 50, remember cos 50, close your bracket, okay? Multiplied by 5 gives us 4.8248. Again, I want that to 3SF. So 1, 2, 3, look to the one to the right of it, and it's not 5 and above, so we keep it the same, so it's going to be 4.82 centimeters, okay? Now, we're going to do a wee bit harder of one where we need to rearrange, and it's the one on the top line that we are missing, okay? So let's try this one. Here is my right angle, my angle of 64 degrees. We have 4 centimeters and we have x centimeters. Centimeters. So here we go. First thing, what's the topic? Trig. How do we know? Angle, side, side. So it has to be trig. Let's write our SOHCAHTOA, our acronym, SOHCAHTOA. Okay, so we know it's trig. It's not Pythagoras because we have an angle. And we want to find the side, so we're going to use trig. So let's shade what we have once we've labelled it. So the side opposite the angle is opposite, okay? Then opposite the right angle, we remember from Pythagoras, is going to be the hypotenuse, and the side on the same side as both angles is the adjacent. Let's take off what we have. So we have O, okay? And we want to find H. So the one we're going to use is sine. So we say sine theta equals O over H. Hard part done. All we have to do now, same as every single time, substitute in our values. So sine theta is 40 equals O, which is 4 over H, which is the one we want to find. So I might actually call that X. Now we've done a sine, cosine and tan. These are the other ones that people struggle with, okay? So it's where there's a little bit more rearranging. So if you're not a big fan of algebra, some people find this quite difficult. Remember, we want to find this value. We want the value of x. So again, we want everything on one line. So I'm going to take the x to the other side. It's being divided by x on the right hand side, so it's going to be multiplying by x on the left hand side. So sine 64 times x equals 4. Okay, the x is positive, that's great, but it's not by itself. So what I'm going to do is I am going to take the sine 64 to the other side of the equal sign. So x equals, write the 4, it didn't go anywhere. It's being multiplied by sine 64 on the left hand side. So therefore it's going to be change sign. If it's multiplying on the left, it's going to become dividing on the right. So divided by sine 64, so x equals. Don't let this little extra bit of rearranging make these seem difficult, because they're really not. We didn't do anything different in this question. We identified it was trig, we labelled it, we decided we were using sine, we wrote our formula, we substituted in our numbers, and now all we've done is apply the rules of rearranging formula to get x by itself and positive. Okay, so then we can say 4 divided by sine 64, don't forget to close your bracket, gives me 4.347. Again, let's do 3 significant figures. Gives me x equals 1, 2, 3, round up because the one to the right of it is 7, 4.35 centimetres. Okay, so hopefully that all makes sense, and if you want any further questions on that, please do comment below and let me know, and I can do another video. But this is trigonometry in finding sides. I'm sure you know life's never that easy, so there also is the extension of finding the angles, which involves a little tiny step, which sides does not involve. So I will hopefully be uploading another video at some point covering trigonometry for angles. Okay, so hopefully that helps, and take care. All the best.